Hello everyone, how's it going? My name is Dan the Tutor. In this video, we're going to be talking about ionic compounds. So first, an ionic compound is basically any two elements or groups of elements that are going to be combined by transferring electrons from one to the other. And basically, the number one thing you need to know is what the elements tend to like to do. So for instance, everything in the first column, this hydrogen column, is typically going to be 1 plus for its charge. The reason why is because they have one extra valence electron in their electron shell. And honestly, that part's not even important. What's important is that you just remember it's usually going to be 1 plus. Then for everything in group 2, this beryllium column, that is usually 2 plus. Everything in the transition metals is basically a crapshoot. It can be anything, 1 plus, all the way up to 4 plus. So for that reason, the problem is usually going to tell you what the charge is for the transition metals. I'm not even going to be looking at them today. And then going from right to left, on the other side, the noble gases, I'm going to say 0, no charge. You're probably never going to see a noble gas in an ionic compound. Then for the halogens, the fluorine family, they're going to form 1 minus, and that's because they have 7 valence electrons and they just want 1 more to complete their electron shell. Again, that part doesn't matter, just remember the 1 minus. Oxygen family is going to be 2 minus, nitrogen family is going to be 3 minus, and usually we don't deal with these elements in the boron or the carbon families. It's just not typical in a year 1 chemistry class. And with that, let's look at some examples. So let's say I want to form an ionic compound with Li, lithium, and F, fluorine. What would the ionic compound look like and what would its name be? So first, if we want to combine Li and F, I look at those two elements on the periodic table. So lithium's here, fluorine's here. Since lithium likes to be 1 plus and fluorine likes to be 1 minus, those charges are even. 1 plus cancels out with 1 minus, which means that when I form the compound, I can just write them next to each other. Li, capital F, and that's the empirical formula. I don't need to write the charges, it doesn't matter. The only other thing I could say is the name of this, which is going to be lithium fluoride. You'll notice the first name stayed the same, but the second name always gets an IDE ending. I shouldn't say always, but most of the time it does. So remember, it used to be called fluorine, but now that it's an ionic compound, we call it fluoride. And so just looking at the periodic table real quick, that means we're going to have chlorine turn into chloride, bromine turn into bromide, sulfur turn into sulfide, and phosphorus turn into phosphide. Like there's just a bunch of examples like that. So now let's do another example. Let's say I want to combine magnesium, Mg, and I want to combine nitrogen, N. This is a much harder example. The reason why, if we look at these elements, we have Mg over here in the 2 plus category, and nitrogen is over here in the 3 minus. So if you want to form an ionic compound with these two things, notice the charges are not balanced. And that's because magnesium is 2 plus, nitrogen is 3 minus. So let me write that down here. Mg 2 plus and N 3 minus. Now if I want to combine these two to make the net charge 0, which is what I want, it's kind of like a math question now. I just ask myself, what do I multiply by magnesium to get the charges to cancel out? And the answer is I'm going to multiply magnesium by 3 and I'm going to multiply nitrogen by 2. And look what happens when I do this. It's going to be like magnesium 6 plus and nitrogen 6 minus, because 2 times 3 is 6, 3 times 2 is 6. Keep in mind you would never actually write it like this. I'm only showing this for demonstration purposes. But the way you would finally write this is you would write Mg3 at the subscript below. Notice I'm not writing the superscript. I'm not writing 2 plus or 6 plus or anything. And then I'm going to say we had times 2 for nitrogen. Okay, so N with a little 2 next to it. And this is the answer. If that is confusing to you, I encourage you to rewatch this part of the video. I think it will make more sense the second time around. And again, giving this thing a name, we would call it magnesium, and then nitrogen turns into nitride. And there we go. That's the name. Here's the compound. Everything's balanced. We're happy. Now let's do one more example. I encourage you to do this one on your own. We have Sr strontium and Br bromine. And what's this going to look like when we combine them together? So go ahead, pause the video, here's the periodic table if you need help, and unpause it when you're ready to see the solution. Okay, so here is what we do. First, strontium is over here in the 2+ category, and bromine is over here in the 1-. So let me just write that down below. Sr is 2+, Br is 1-. Typically when we have 1-, we don't actually write the 1, we'll just write minus. Doesn't really matter. But now it's not balanced because strontium's 2+ and bromine is only 1-. What do? I multiply bromine by 2, and so that means when I combine them together, it's Sr with only 1, and whenever it's 1, you don't write the 1. And then right next to it, I write Br2 because we just said there's 2 bromines. That makes the charge balance to 0. And there's our answer for the formula. And the name of this would be called strontium bromide. IDE ending. Okay, and there we go. There's some easy examples. Well, I don't know how easy they are, but these are pretty easy in the grand scheme of things. There was no tricks I threw at you. There's not going to be too many tricks. The only thing they could really do to mess us up is if they gave us a weird transition metal. Like, for instance, copper is famous because copper can either be 1+ or it can be 2+ when it forms an ion. So they have to tell us in the problem what that is. But that's going to do it for this video. Thank you all for watching, and I hope to see you in the next one. Take care, and bye-bye.